Hello, everybody. My name is Žorž. I come from Slovenia. I work for Internet Society. And today I would like to talk about something that is not an ISOC thing, as Peter would say. It's a community document. How it all started. I'm traveling a lot around the world, talking to many operators around the world, asking them why they are so slow in deploying IPv6. And when I see the pattern, the generic pattern of a problem that they are telling me, then I say, okay, we should respond, we should write a document that is answering this problem. That's how RIPE 501 and RIPE 554 started, for the operators to be able to request IPv6 requirements when they're buying the equipment. That's how RIPE 631 started. That is talking about how the help desks should troubleshoot the IPv6 problems when people calls in. And then after some time, I heard people saying, okay, what is the prefix that we should delegate to our end users? And people around the world were guessing. They were saying, we should do /64, we should do /48, we should do /56. What should we do? And when I heard this question many times, then I decided, okay, let's put together a good group of operators, of good IPv6 experts, and let's answer this question. So what I will be talking about is basically a community document that we as a group of authors became basically just the humble editors from all the feedback that we got back from the RIPE IPv6 working group and the wider community around the world. So, who in this room is the operator and is busy implementing IPv6 right now? Show hands. Okay. After in a coffee break, I would be eager to hear from you how you decided on your prefix delegation to your end users. But what is this document all about? Actually, if you make the wrong choice at the beginning when you're deploying IPv6, if you choose wrongly what to delegate to your users, you might have problems later. And you might have to redo everything from the scratch. As you see, these are the co-authors. There are some really good IPv6 experts. I was happy to put these people together. You see many people from, for example, Andrew Alston from Liquid Telecom. That's the biggest operator in Africa. We have Slovenian Telecom. We have lots of good people here. Okay. First of all, I would like to thank Internet Society to let me me work on this in my work time, because this is not directly ISOC related. I'm sure you will hear in these 2 days more about Internet Society. I hear they're very busy with manners and routing security stuff here in Sweden. But let's get back to this document. This is a table of contents. As you can see here, what we are discussing here is the number 4 is where it gets interesting. This is the sign of end user prefix assignment. Is it /48, /56, or something else? And then we go into numbering the one link. How should you number the one link? And then we go, should you go /64? Should you go unnumbered? Should you go with the unique local addresses? Then we go into v6 prefix out of the IPv6 prefix assigned by the end user and the summary. Then we go into the prefix assignment options, and we discuss about, should we go /48 for everybody? That's my personal favorite. Should we go /48 for business customers and /56 for residential customers? Should we go with prefixes longer than 56? No, don't do it. And considerations for cellular operators. And then we come to the interesting part. When people get confused, usually, should the prefix that we assign to the end user be persistent, or should it change over time? And here where things get interesting, because operators tend to learn from IPv4, but also tend to bring bad behavior from IPv4 into IPv6. And that's not good. That's not the way of doing it. So here we discuss why not persistent assignments may be perceived as easier. Of course. You put up your BRAS or whatever you have, you put IPv6 pool there, and then you leave to equipment to assign it as it wants. It's much easier, but is it good? Well, here we figured out it's not. Then we discuss why not persistent assignments are considered harmful, and why persistent prefix assignments are recommended. So, I will not read you the whole document, but this is just the generic set of recommendations. IPv6 is not the same as IPv4. In IPv6, we don't count IPs. We have prefixes that has their own type of usage. /64 is one LAN, is one layer 3 domain. /56 is for something else, /48 is for something else, /32 or /29 is the assignment to the LAR. We don't count numbers. You should not be concerned by exhausting IPv6. You will not exhaust it anytime soon. So if you need more space, go back to the RIR and they will give you more space. RIPE will happily give you more space. So I've seen many people doing their address planning, and usually they fail 3 or 4 times. Don't be afraid to fail. First time, they make it very packed and they don't use much addresses, and then they figure out they did it wrong. Don't be afraid to just throw it into the bin and do addressing again. And then I usually see people making the address planning quite relaxed, and then they exhaust their IPv6 space, and they go like, okay, we are not going back to RIPE NCC and ask for more space. And then on third time, they make it right. Don't be afraid to break some glass. If you want to make it easier for you, consider this. My personal favorite is /48 for every customer. Lots of also other organizations are considering this as the safest option. It works well. It makes your routing table quite simple and easy to organize. I've heard concerns about this, but basically mostly from sales and marketing people. And they say, oh, now we are differentiating between our business customers and residential users. And we are giving business customers more of resources than to residential users. And we're like, well, yeah, technically there is no need to do that, but if you really want, you can give /48 to business customers and /56 to your end users. And then they go like, okay, if that's technically feasible, then we are going to do this. It's quite easy. There is always a trade-off, but my personal preference is /48 for everybody, and then it's much easier to do. You need to understand that there is a specific case for cellular phones Mobile phones, they, if you decide to go on IPv6 only for your mobile phones, the PDPv6 context that you establish, usually /64 is given to every phone. So that's a little bit different. All right. The one links. If you don't want to get into trouble with troubleshooting, you should not consider using ULAs or unnumbered links on the one, but use the global unicast addresses on your one links to connect your CPEs to your core network. Why? Because if prefix delegation fails, then you will be able to troubleshoot from the CPE, from the customer, towards your network. If you don't give the number to the one link, then your troubleshooting may get messier. Yeah, there is also a consideration for /127 for each point-to-point link. That's perfectly valid if your equipment supports it. But please consider reserving /64 for each customer and just use /127 for the one link. This makes it much easier for everybody. Okay, non-persistent prefixes. Why are they considered harmful? I'll tell you a story. For example, Liquid Telecom in Africa. They started deploying IPv6 for many customers in Kenya, Zimbabwe, and things like this. And then all of a sudden, my friend that is responsible for that there comes over Facebook chat and goes, oh, I'm having problems with Google not serving me quad A's. Wow. Why is this happening? And then I asked him, did you deploy your IPv6 with changing prefix delegations to your customers? And he said, of course. I said, I told you not to do it. He said, well, I did. What is the problem? What happened actually is, for example, in Kenya, there are lots of power outages. If you have been to Kenya, you have experienced the power outage every day, basically. So what happened was, when there is a power outage, the CPE does not remember the previous prefix that was delegated to this user. And you have a laptop sitting on your network at home. You have IPv6 address that is from the prefix that was delegated to you, and you're trying to communicate with the internet. Power outage, CPE reboots. After CPE comes back, it gets a new prefix. And because the CPE is not aware of the previous prefix, it doesn't send the array packet with lifetime 0 to basically discard the old prefix on the network, but starts just advertising the new prefix. And your laptop gets the IPv6 address from the new prefix. But according to the Murphy's law, that one is not used. It still uses the old one. So what happens is, you try to access Google. You send a SYN packet. And this packet finds its way, because of default routes, to Google. Google sends you back the ACK packet. But this packet never comes back to you, because there is no route back to you. There is no, the old prefix is not valid anymore. And Google is then expecting the SYN ACK from you. But it never gets the SYN ACK from you, because you are communicating from the old IPv6 address. What happens? They're measuring that. If they don't get the SYN ACK packet from you, they mark your network as broken IPv6 implementation, and they stop serving you quad A records. And these people was in panic. And I explained them this. Look, this is what you're actually doing. If you don't have the CPE that remembers the prefix delegations over power outages, and after it comes back, if the prefix delegation is not the same, start sending array packets with lifetime 0 as crazy to the network, then you're having a problem. And what they did was they needed 3 or 4 days to reconfigure the whole network, and they did basically static prefix delegations to all their users. So this is the recommendation. If you don't have the control over your CPE, and if your CPE vendor did not implement the function to remember prefix delegation over power boots, then do static. If you really know what you're doing and you're sure that things would work, then you can go dynamic, but reconsider things. Oh yeah, this was the authors of this document. This is Andrew. He's from Africa. He was the one having problems, and why we included this part of the. So as you can see, the editing of this document was quite relaxed. But I'm really happy because majority of stuff here also came from the community. We received lots of comments, feedback from the community, and I'm really happy that it got so wide consensus that we can consider it a really best current operational practice. Here are the acknowledgements. As you can see, many people was involved in this document other than the co-authors. And here is where you can find the document. It's free, it's yours. If you want to use it, use it. It's really the best current practice. What is the future work and ideas? We're thinking about a document that is talking about how to run your mail server on IPv6, because I've heard lately when I'm asking operators around the world why you're not running your email on IPv6, and they go like, anti-spam mechanisms are not there, there is no IP reputation mechanism to prevent people from sending me spam. How to survive on IPv6 because spam and things like this. So we thought about writing the best current operational practice on this topic. So if you are running your mail server on IPv6 and you have some operational experience in that, come and talk to me. We are now looking for the group of the authors and people who would work on that. And with that, are there any questions?
So we have quite some time. So if there are any questions for Jan, you have him available here. Anyone operating? Yes, Marco, please, in the middle there.
Oh boy.
Thank you, Marco Groninger, NCC. It was actually a question to you, Rob, or basically to the room. How many people have read this document, and how many people have actually sort of applied the recommendations of this document into the network? I'm just curious to see how far that's been taken here. That's
a great question, Marco. So can we have a show of hands, number of people that have read the RIPE 690? Okay. I'd say that was 10-ish at a rough count. What was the second part of the question, Marco? Sorry.
Whether they applied it to their network.
And so of those of you that have read it, put hands up one more time, the people that have read the document, sorry. Okay, so for those of you that have read it, keep your hands up. If you've applied that document, please keep your hands up. Okay, a few hands went down. Okay.
Okay, it's just the generic recommendation. It's not set in stone, but it's basically the lowest common denominators. What we heard from operators that they are doing and survive in deploying IPv6. You need to. I need to emphasize, deploying IPv6. It's not hard. the decisions while deploying IPv6 sometimes are hard because we are thinking with IPv4 in mind. And we are writing these documents to make it easier for you to do some decisions. You know, and I'm happy when in the document, after it closes the editing cycle, it comes from the community something that sometimes I even don't entirely agree, but you know, if that's the will of the community, if that's the feedback from the community, who am I to argue? So this is basically the completely community feedback and the advice. Okay, there are no other questions, so I will just...
Any more questions for Jan? No?
Nope.
Well, thank you.
Thank you very
Please
much.
join me in thanking Jan.
Thank you.